Welcome. This paper introduces an improved method for classifying breast cancer patients by combining ensemble clustering and ensemble classification. This research was conducted by these following authors. Traditional ensemble clustering methods leave some patients unclassified, which limits their usefulness in clinical decision-making. This research solves that problem by adding an ensemble classification step, ensuring more patients are assigned to meaningful groups. The approach was tested on real-world breast cancer data and validated with standard machine learning datasets. The methodology consists of 5 key steps. First, the data is pre-processed and cleaned. Second, ensemble clustering is applied using k-means and partitioning around medoids to identify core patient groups. Third, some patients remain unclustered, so ensemble classification is introduced using artificial neural networks and nearest neighbor classifiers. Fourth, the classifier outputs are merged using unanimous voting for accuracy. Finally, the refined classification is evaluated using statistical tests, box plots, and cluster validity indices. This is a visual representation of the methodology used within the research. You can pause the video to gain more understanding. Soria et al. Used ensemble clustering but left some patients unclassified. This paper improves on that by adding ensemble classification. Bashir et al. Demonstrated that ensemble classifiers outperform single classifiers in medical diagnosis. This study builds upon that by using ANN and nearest neighbor classifiers to improve accuracy. The data is tabular, static, structured, and contains multivariate biomarker levels from 10 proteins. The pipeline was evaluated using statistical analysis for cluster quality, box plots for visual comparison of biomarker distributions, machine learning techniques for enhanced patient assignment through clustering and classification. This is a visual of the analysis techniques used within the research. The Edinburgh Breast Cancer Series dataset achieved an accuracy boost from 89% to 97% using ensemble classification. Classifications were verified by clinical experts to ensure biological relevance. The pipeline's performance was rigorously validated and demonstrated generalizability on UCI datasets like IRIS and WINE, showing significant performance improvements. Results were also further benchmarked against previous research. Thank you for watching and listening.